Today we are working through IB Maths, AA, tangents and normals. This is a classic exam skill. Differentiate first, find the exact point on the curve, and then build the equation of the line. We will cover the concept, then work through two exam-style questions step by step. Start with the tangent. A tangent is a straight line that touches the curve at one point, and at that point it has the same gradient as the curve. In IB Maths, the gradient of the curve comes from the derivative. So if the curve is y equals f of x, then the tangent gradient at x equals a is f prime of a. The common mistake is to stop after differentiating. That only gives the gradient. To write the equation of the tangent, you also need the exact point on the curve. So the method is, substitute the x value into the original function to find y, differentiate the function, substitute the x value into the derivative to find the gradient, and then use the point and the gradient to write the line equation. Now look at the normal. The normal is perpendicular to the tangent, so its gradient is not the same. If the tangent gradient is m, the normal gradient is -1 over m. That negative reciprocal is where many students lose a mark. If the tangent gradient is 2, the normal gradient is -1/2. If the tangent gradient is -3, the normal gradient is 1/3. Once you have the normal gradient, the rest is the same line method. Use the same point on the curve, and substitute into y minus y1 equals m times x minus x1. So for both tangent and normal questions, the two ingredients are always the same, the exact point and the correct gradient. For question 1, the curve is y equals x squared minus 4x plus 7, and we need the tangent and the normal at x equals 3. First, find the point. Substitute x equals 3 into the original equation. 3 squared is 9, minus 12, plus 7, so y equals 4. The point is 3, 4. Next, differentiate the curve. The derivative of x squared is 2x, the derivative of -4x is -4, and the constant disappears. So dy by dx equals 2x minus 4. At x equals 3, the tangent gradient is 2 times 3 minus 4, which is 2. Now write the tangent equation using y minus y1 equals m times x minus x1. That gives y minus 4 equals 2 times x minus 3. Expanding gives y equals 2x minus 2. For the normal, use the negative reciprocal of 2, which is -1/2. So the normal is y minus 4 equals -1/2 times x minus 3. In an exam, you can leave it in this form unless the question asks for a particular form. Question 2 is slightly deeper because we have to find a parameter first. The curve is y equals x squared plus kx plus 5, and the tangent at x equals 1 is parallel to the line y equals 4x minus 3. The key word is parallel. Parallel lines have the same gradient, so the tangent gradient must be 4. Differentiate the curve. dy by dx equals 2x plus k. At x equals 1, that becomes 2 plus k. Set this equal to the gradient 4, so 2 plus k equals 4, and k equals 2. Now substitute x equals 1 into the original curve, using k equals 2. We get y equals 1 squared plus 2 times 1 plus 5, so y equals 8. The point is 1, 8. Finally, use the gradient 4 and the point 1, 8. So y minus 8 equals 4 times x minus 1, and the tangent equation is y equals 4x plus 4. This question is a good example of why you must connect the wording to the method. Parallel tells you the gradient before you find the equation. Question 3 adds one more common IB Maths function. We need the normal to y equals natural log x plus x squared at x equals 1. First, find the point from the original curve. Natural log of 1 is 0 and 1 squared is 1, so the y value is 1. The point is 1, 1. Now, differentiate. The derivative of natural log x is 1 over x, and the derivative of x squared is 2x, so f prime of x equals 1 over x plus 2x. At x equals 1, that gives 1 plus 2, so the tangent gradient is 3. Because we need the normal, take the negative reciprocal. The normal gradient is -1/3. Finally, use point-slope form. Y minus 1 equals -1/3 times x minus 1. This is a strong check question because it tests the differentiation, exact substitution, and the normal gradient rule together. For scoring, keep this order. First, write down f prime of x. Second, find the exact point on the curve from the original equation, not from the derivative. Third, for a tangent, use f prime of a as the gradient. Fourth, for a normal, use the negative reciprocal. The most common mistake is mixing up the tangent gradient and the normal gradient. A quick check is this. Tangent and normal gradients should multiply to -1. If they do, your gradient relationship is correct. Keep practicing with real exam questions on EduNinja. Build papers by topic, follow step-by-step solutions, and review smarter at eduninja.net.